Alright, so some people might ask what the ByteBuf is, what the ByteBuf is, or what the ByteBuffer is. So ByteBuffer, it's a memory. ByteBuffer, it's a memory, and there are two types of ByteBuffer. It's the heap ByteBuffer. So the heap ByteBuffer is allocated inside the JVM heap memory. So it's the JVM allocate the memory. And there's another one called direct ByteBuffer. So the direct ByteBuffer is the native memory. So it's not allocated from by the JVM. It's allocated by the system. So we say that it's allocated outside the JVM heap, right? So it's two types of the ByteBuffer, and let's look at how we can manipulate this ByteBuffer. In the JDK, there is a class called ByteBuffer class. Then you can call a static method allocate, and you can give you can pass it a capacity. If you say 128, then 128K, right? Then you can get a ByteBuffer. You can get a ByteBuffer here. And also, but this ByteBuffer, it's a heap ByteBuffer if you call allocate. So if you want to get a direct ByteBuffer, you can use that. You can call allocate direct 128, and then this ByteBuffer, it's the direct ByteBuffer. It's from the system. It's a native memory. Okay, so Netty, this one ByteBuf, it's similar to ByteBuffer. ByteBuffer is provided by Java in the NIO package, but ByteBuf it's provided by Netty. So obviously, this ByteBuf is an advanced replacement for ByteBuffer. So ByteBuf is an advanced replacement for ByteBuffer because they have so many advantages over ByteBuffer. First one is the ByteBuf separates reads and writes index pointers. Now in the this is for the JDK, right? So if you want to change, if you want to switch between the reader index and the writer index, you need to call a flip method. And this is very hard to manipulate because sometimes you know it's not user friendly. So in Netty, the ByteBuf it maintains two pointers: the reader index, the reader pointer, and the writer pointer, which is it's much easier for us to manipulate. And also it provides better performance for slicing, duplication, something like that. And it read and write primitive types directly, so very easy to use, right? So that's the ByteBuf. And which one is better? If I have a question, I mean this is the interview question. Heaped versus direct, which one is better? It depends. On heaps, let's say we say that heaped, the JVM heaped memory backed by a regular Java bytes, and also faster allocation. But there's a bad thing, subject to GC. Now you know if you keep manipulating the Java heap, and it may trigger the GC. So this is the bad side. If you have a very, very regular heap memory allocated from JVM, then you probably cause GC more regularly, more often, more frequently. So that's something that we don't want to see, right? So basically, if you want to do some I/O operation, if you have so many I/O operations that you are going to do, then please keep in mind that do not consider the heap memory. Try to use the direct memory, right? If as long as you have I/O operations, don't even think about heap memory, because it has a very bad performance. All right, so there's another concept. When we mention the ByteBuffer, there's pull and unpull. Pull and unpull. So what does it mean by pull buffer? Pull buffer, what does it mean? Pull buffer means reuse previously allocated memory chunks. So that means if you create a pull buffer memory, when you finish using it, it's not going to be destroyed. Our system will keep this memory chunk somewhere, and next time if you're going to use it, and then you take it out and use it again. So we say reuse previously allocated memory chunks. So this is called like a thread pool, similar to thread pool. Now we know that thread pool is just you put the thread in the pool, and when you finish using it, you put it back to the pool, and the next time you use it, you take it from the pool. Okay, exactly the same concept, right? So pull buffer is used in the case when you have a regular access to the memory. Then you consider the pull buffer, and you can use the unpull buffer as well. Unpull buffer, there's a class called unpull, and provided by Netty, and then you can simply allocate. Just buffer, sorry, and then you get this buffer, and you get this ByteBuffer. That's an unpull buffer. So it's only once, use only once. When you finish use it, it destroyed. Okay, so if you send a message once, only send out, the message is not going to manipulate, or you don't do anything else, and just send the message out once, and then you can consider the unpull. Alright, so because unpull means it's created every time you call this method, it's going to create the memory block, and then so it's always the performance. In terms of the performance, it's worse than the pull ByteBuffer. So so it depends on how you use it. All right. So the frequent heap allocation slow down the system. Frequent heap allocation slows down the system. Alright, so this is because the creating thousands of small byte array or ByteBuffer heap objects leads to frequent GC. Yeah, and this pause, when GC occurs, it pauses your application, especially in high throughput systems, high throughput systems like web servers or RPC frameworks. So if you don't want this to happen, okay? All right, so let's come back to Netty. So what Netty is default to use? Netty use something like that. Netty default to use pulled direct buffer. So we can look at this one. It's called pull ByteBuffer allocator.default. This is default. This is the default by Netty. So let's look at that. We can look at the source code and default. Where can I see the default? Here, default new pull ByteBuf allocator, and there is a boolean value. It's default to be true. Direct buffer prefer default to be true. So Netty is used to pull direct buffer, right? So we can, if we go back to the server here, you can set it. You can set it as a child option, channel option dot allocator. So Netty by default is called pulled ByteBuf allocator default. So if you don't add this line, this is what Netty default. Okay, so this is what Netty default. So if you don't want to, if one day you say that, okay, I don't need this direct buffer, I want to have the buffer from the heap, from the JVM heap, we can do it. Because by looking at the default, right, it's just simply newed an instance of pull ByteBuffer allocator. So we new one, and here I said that it's default to be true, meaning that using the direct buffer. And now, if you don't want to use the direct buffer, you give them a false. All right. So simply we can new a pulled ByteBuf allocator and give it a false, and that's it. Once you add this line of code into your Netty server, your Netty is not going to allocate any direct buffer to it, to any channel. Okay, so this is not good. Think about that. If you really have this need, then you can do it. But I don't see in the development, I don't see any need that you need to you must switch off the pulled ByteBuf allocator. I don't know. I don't see any requirement like this in my experience. So we don't have to do it. Just remove this line of code. I mean, you can do it, right? So if you really want to do it, then you can follow that and switch that off. Okay. All right. So we finished introducing the ByteBuf in Netty, and then you know that right now it's just a memory block, and then it's a memory block so that we can put whatever we want into that memory, and then so this memory is accessible in the pipeline and in the channel. Okay, so I will have more ByteBuf knowledge later on, so don't rush. Okay.